Hello, we are Who Ate All the Pie. If you cannot feed 100 people, then feed just one.
Hunger is a prevalent issue in the world, making it number 2 of the 17 UN Sustainable Development Goals. For example, it is recommended that between 10 to 35% of an adult daily calorie intake should come from protein. Unfortunately, an eighth of the population are struggling to meet this. There are various factors leading to hunger, such as poverty, climate change, and overpopulation. Our idea is to fix this by farming and feeding on insects.
Why entomophagy? First, it has a lower carbon footprint than other forms of protein sources like beef, and also less trees would have to be cut down rearing livestock. Secondly, with limited resources, edible insects require less land and water to feed, making it more sustainable. Thirdly, the consumption of insects of some form is already common in southern Africa, so our plan is not an invasive intervention for the local species.
Here, our idea focuses on Madagascar, where 2/3 of the population already has insects as part of their diet. Moreover, the climate in Madagascar is suitable for their survival all year round, with 2 main seasons recognized: a dry winter from May to early September and a green summer from mid-September to April. The average annual temperature ranges from 23 to 27 degrees. Even under this minimum temperature, crickets are able to survive and reproduce, with summer being their optimal temperature.
4 million people, which is equivalent to 28% of the rural households, are suffering from the inability to access food. This could be accounted for by natural hazards, which are exacerbated by climate change, leading to the compromise of food production in the southern region of Madagascar.
Why crickets? This is because they are common in many places around the world and are widely available as a food source for pet amphibians. Our first batch of it can be easily sourced due to this. Although crickets alone would not be enough for a balanced diet, they are high in protein and contain fatty acids, as well as other vital micronutrients such as iron, zinc, copper, magnesium, and vitamin B12 in a higher quantity than beef. Here, the families could catch the crickets using nets made from thin excess fabric, where the smaller insects would not be trapped. In order to lure the insects, lighter food which is not consumable by humans, such as banana peel or crushed corn cobs, would be suitable.
This insect rearing system our team came up with is designed to be sustainable and fitting for small-scale usage, with minimum cost and technology. This is done to help people that are most impacted, those who are in poverty. In our first cricket rearing model, we used a 1-liter plastic bottle with 2 cardboard pieces fitted perpendicularly inside for the cricket to climb. This will later be beneficial for their removal at the end of the rearing process. This also restricts the movement of the insect, so more energy can be conserved for growth. For our feeding and hydration system, we chose a detachable food and water supply, as shown here. Water is fed through soft sponge to prevent the cricket from drowning and also to maintain the humidity. Most of the food used to feed these cricket would be parts of plants that are indigestible for humans, as so not to deplete the already limited food source of the carrier. The diet of the cricket consists of a variety of leafy decaying plants and grains, which mean that they are able to survive on most local species or agriculture in the area implemented. In terms of reproduction of crickets, from research we learned that they lay eggs in humid conditions using their ovipositor, which is a tube-like organ, and they may also consume their own eggs. After consultation with our mentor, he suggested many improvements we could make to the design. Firstly, we've decided on using a larger bottle to give them more living space. We've also cut out bits of laundry bag to cover the soil to prevent the cricket from eating their eggs. Our teacher had also suggested that wet sponge may not be necessary, as crickets could live off the moisture from the vegetable given as food. Also, a feeding model may be too complex for the crickets to reliably find the food and feed on it. To address this problem, we decided to simplify the system into just supplying the food through the bottle cap. This time we've considered the potential killing method that we have missed while making the first model. Drowning is the most suitable. However, if a household does possess a refrigerator, they may use it instead.
Plans to overcome the fear of entomophagy are to incorporate it in familiar meals such as yogurt, salads, or changing up the ways in which it is consumed, such as having it fried or roasted with garlic salt and chili powder. We've also invited some of our friends to try it out.
All in all, if this is successful with a small family, it could be implemented to other families in the local area. Eventually, with the other countries in the world with their own native species of insect that will survive in the immediate climate. Therefore, by feeding one family at a time, in only a matter of time, 100 families would be fed, and hunger would not foster.